Welcome to the course on VLSI physical design with timing analysis. In this lecture, we will discuss some more clock routing algorithms. The content of this lecture includes method of means and medians approach for clock tree synthesis. Then the second approach is recursive geometric matching based clock tree synthesis. So, the clock tree synthesis is one of the important tasks for a VLSI physical design person. So, it is very important to understand how the clock tree is inserted in a VLSI physical design flow. So, what is the purpose here is to distinguish different approaches, because it will help us to solve the skew problem in the clock tree. So, the first most interesting algorithm is called the method of means and medians. So, here it was proposed to overcome the topology limitations of the H tree. Here what is the basic idea is basically we will recursively partition all the sink terminals. So, the sink terminals are basically your location of your flip flops and the latches. Okay. So, what we are doing here is that we are partitioning the number of flip flop and latches in the design into subsets. Okay. And whenever we are creating the subsets of the overall set, we maintain the same number of sink node in each subsets. So, then we will find the center of mass of the set. Okay. We will find the center of mass of the set, and that is connected to the center of mass of the two subsets. So, we will find the center of mass of the set, and we will find the center of mass of the two subsets and connect them. So, in this method we will find the clock tree. So, we will discuss the method. This is the pseudocode for the MMM algorithm, method of means and medians. Okay. So, first of all we will see what is input to the algorithm and what is coming out of the algorithm. The input to the algorithm is a set of sink node that is denoted by S. Okay. So, the sink node, whatever I told earlier, is the number of flip flops and latches in the design. Then we have a empty tree which is having no element in that tree. Okay. So, initially we have a empty tree and set of sinks going as input to the algorithm, and what is coming out? We are getting the finally the clock tree, final clock tree, how it is routed. So, here the condition is that if the cardinality or the mod of S is less than 1, means that there is no element in that set, then we will terminate the algorithm, otherwise we will continue this algorithm. So, first of all we will find the center of mass of S, find the center of mass of the S. So, what is the center of mass? Let us say I have 4 points. So, let us say this is x 1 comma y 1, this is x 2 comma y 2, let us say this is x 3 comma y 3, then it is x 4 comma y 4. Then the center of mass of these 4 points can be found out of in both the direction x and y. So, let us say this x 0 is the center of mass in the x direction. So, this will be x 1 plus x 2 plus x 3 plus x 4 divided by 4. So, we can write this one as summation I equal to 1 to 4 x I by 4. Okay. So, similarly, this is for x coordinate. So, this is for x coordinate. Similarly, I can do it for y coordinate. Y 0 will be y 1 plus y 2 plus y 3 plus y 4 divided by 4. So, similarly, I can write summation I equal to 1 to 4 y I divided by 4. So, this is corresponding to the y coordinate. So, for this one we found out x 0 and y 0, which is given here. Now, what we have to do is that we partition the set into two subsets like S A and S B. What is input to the partition is S, which is basically the union, S is union of S A and S B. So, what we are doing here is that we are partitioning based on finding the median. Median means we are partition the set S into two parts such that each partition will have equal number of sink nodes. So, I have S A and S B. I have a set S A, then I will find the center of mass of S A, then which is found out to be X A and Y A. Similarly, the center of mass of S B is basically X B comma Y B. Now, what we are doing? We have found three center of mass. One is corresponding to S, that is x 0 comma y 0. Then we have S A, we have a center mass S A comma y A. Then S B, which is basically center mass is basically is x b comma y b. So, now I have three center of mass, then I will connect. So, how should I connect? I will connect the center of mass basically x 0 y 0 with x a y a using a metal segment. Then, so basically I will repeat for set B, correct. So, this first one, this is, let us say this is the first one is given here, the first one, this is the one step. The second step is this one is the second step is done here. Now, I did the routing and connect the center of masses. Then I will do this thing recursively and I call this same function, same basic MMM recursively till I find the basically the leaf nodes, whatever the constraint it is given in the starting of the algorithm. So, this is the basically recursive algorithm and it use the concept of means and medians. So, we have already discussed this one, again I am repeating. So, here for each subsets I am finding the mean of x coordinate and y coordinate, and which is nothing but my center of mass point of the set S. So, this is giving corresponding to x coordinate, this is corresponding to my y coordinate. Okay. Then I will show you the procedure here. So, basically if you can see I have these are my sink nodes actually, these black dots are the sink nodes. Then I find the center of mass or center of gravity, which is found to be this point. So, this is my center of gravity or center of mass. So, now what I have to do? I have to divide this whole set into two partitions, partition A and partition B. So, how do I do the partition? Based on cardinality of each of the subsets. So, the cardinality of the each subset should be equal. So, if what I did? I have here 1, 2, 3, 4, 5, 6, 7, 8, 8 sink node in partition A. Let us say this is partition A and this is partition B. It has also 1, 2, 3, 4, 5, 6, 7, 8. So, here I have 8 nodes, sink nodes, here I have also 8 sink nodes. Now, I have to repeat the same center of mass concept for the sub partitions. So, I found for partition A. So, this is my center of mass and this partition B, this is my center of mass. So, now I find the center of mass for both the partitions. Now, we have a center of mass of the overall set. So, I need to connect them, I need to connect all of them. So, this is x 0 comma y 0, whatever I showed earlier, this is x a comma y a, then this is x b comma y b. So, now I connect them. I will repeat the same procedure for rest of the nodes and create this kind of clock tree. So, this is one method of finding the clock tree, which is called method of means and medians. So, if we can look into this method, it is basically top down methodology. It works from the top sync node to the bottom sync nodes. There is another approach is there, which is called recursive geometric matching algorithm, which is working from bottom up approach, So, here what is happening is that, what is the basic concept behind this RGM is that we are recursively finding the minimum cost geometric matching of the n sync nodes. So, once we find that, then we find basically set of n by 2 line segment that match in endpoints. Okay. So, we will locally match 2 of the sync node and create n by 2 line segments, such that my total wire length is minimum. So, I have a objective to minimize the wire length, that is my objective. What is my goal? I have to create n by 2 line segment. So, how the line segments are chosen? If 2 sync nodes are near to each other, such that the minimum wire length can be achieved. So, I have to create n by 2 line segment from n endpoints. Okay. So, after I created this n by 2 line segment, for each matching step a balance or tapping point is found. So, what I have to do? Whenever I have a line segment, I have to find a tapping point. So, tapping point will connect one line segment with the other line segment, that is one thing, and it cannot be middle of the line segment also. It depends upon how I can basically maintain 0 clock skew. So, these lines, whatever it is that line segments are there, let us say I will give an example here. So, these are the sync nodes, let us say. Okay. These are the sync nodes, 4 sync nodes are there. So, what I have to do? First of all, I will do 2 line segments. Okay. So, then how I can tap a node in between the line segment? I have to tap a middle of this one and middle of this one, such that my 0 skew is achieved. Okay. So, this is called basically I need to find n by 2 tapping points from the input. So, which one is the tapping point here? These are the tapping points. And this is the line segment. This is the line segment. And these are the actually sync nodes. So, very interesting, it is not very lot of maths is involved here, it is very simple concepts. My goal is to achieve 0 skew. How should I draw the interconnect such that I can achieve 0 skew or minimum skew? 0 skew may not be possible all the case. So, minimum skew as possible. So, here basically n by 2 tapping points will be created from the input line segment to the next matching step. Okay. This process will be repeated till I will get to connect all the nodes or all the nodes in the set. Okay. So, basically this is my pseudo code of the RGM algorithm, recursive geometric matching algorithm. So, if you can see here, what is input to the algorithm? Like the previous algorithm, MMM algorithm, we have the same inputs and similar outputs. We have set of sync node S and a empty tree T, and the output the basically sync node with the clock tree synthesized. The T is basically sync nodes with the clock tree synthesized. The first one is obvious, whenever mod is less than 1, then there is nothing to route, then we will complete the algorithm. So, what I am doing here is that I am finding M, okay, I am finding M, a minimum cost geometric matching over S. So, this S is the set of sinks. So, then I am finding the M. So, initially we have a set S prime which is phi, there is no element in that one. Then we will add elements to that set. So, the M denotes the set of matching pair, okay, Pi comma Pj over S. Okay. So, that procedure will be repeated. So, what we are doing here is that for each pair in that M, okay, matching set, we have a matching set actually, we are taking each pair of points add to the tree. Okay. So, we have a already we have a subtree, okay, we have a subtree of t rooted at Pi, okay. Then we have a Pj which is a subtree rooted at Pj. Then we are creating a tapping point between P and Pj, okay. Then we create a updated tree. So, this tree TP is basically the updated tree, clock tree, where we have this sub trees are there. This is one subtree, this is another subtree, and we are adding one more branch to that subtree. And this branch is connected with the subtree through this tapping point. That is the main point. So, this branch will connect to the tree through the tapping point. So, what is the objective? We have to minimize the clock skew. So, now the TP will be connected to your S prime. So, this step, the last step what it is doing is that we are calling this same RGM recursively till all the elements in the set S is 1. Okay. Element in the set, this process will continue till element in the set S is becomes 1. So, then we will stop the algorithm. So, let us look into how things are happening here. First one, this is the set of sync nodes actually, this is a set of sync nodes. Okay. Then what we are doing here is that we will create the line segment. The second step is basically create the line segment such that my wear length is minimum, my wear length is minimum cost geometric matching we are doing. Okay. So, here let us say how many n sync nodes are there. So, now we have n by 2 line segments. Okay. So, then what we have to find the tapping point in each line segment. Then I need to find the tapping point in each line segments. So, this red dots are the tapping point in the line segment. Remember that this tapping point may not be at the middle of the line segment. So, it depends upon how I can make my clock skew minimum as minimum as possible. So, it is this point tapping point may not be at the middle of the line segment. Now, what I am doing here, I am connecting the tapping points nearby, okay, and create a tree quite similar to H tree, but it is not exactly H tree. So, this is the minimum cost geometric matching possible. Then these sub trees, these are the sub trees actually. Let us say this is S1 subtree, this is S2 subtree, S3 subtree, S4 subtree. Then again we need to find the tapping point in the subtrees. Okay. So, these red lines in these line segments, we need to find the tapping points such that my clock skew will be 0. Now, these tapping points is created and connected. These are the tapping point of the subtrees. Then this is created where my total clock skew should be as minimum as possible. It may not be 0. Okay. So, that is the goal. That is the goal. So, in practice actually this RGM improves the clock tree balance and wear length over MMM compared to MMM algorithm. It improves the wear length and it also balances the clock skew because it works from the local level to the global level. It works from the local sync nodes towards the global clock tree synthesis, CTS. So, that is the reason it is better than MMM algorithm, better than this MMM algorithm. However, we can achieve 0 clock skew in case of MMM algorithm. However, RGB may not guarantee actually 0 skew in this approach. So, so that is one of the limitations, but it will create a balanced clock tree with minimum wavelength. So, if you can see here the comparison between our MMM in the left hand side. So, this is basically the problem statement. I have 4 sync nodes are there. Here I have in this case I have 4 sync nodes are there. Okay. Now, what I am doing? I am doing division, and I can do basically this is the final clock tree after using MMM. Then the same set of problem is given to the RGM algorithm, and this is the final clock tree synthesis. If you can see here, the wavelength is minimum in case of RGM. So, wavelength is minimum, wavelength is minimum in RGM. Okay. So, here if you can see interconnect length is minimum in case of RGM. However, the interconnect length in the clock tree is large in case of MMM algorithm. If your interconnect is larger, then you have more delay in the clock path in case of MMM algorithm, but it is more balanced and it can produce minimum clock skew, but this RGM may not lead to minimum clock skew, but it is targeted at targeted to minimize the total wavelength in the clock tree synthesis procedure. In this lecture, we discuss about 2 popular clock tree synthesis algorithm. One is called MMM, which stands for methods of means and medians. The second method is called RGM, a recursive geometric matching algorithm. We discuss both the algorithm with their advantages and disadvantages with one example. Thank you for your attention.